Hello students, this is the video for 9.7, Boyle's and Charles's Law. So if you remember from when we introduced gas laws, Boyle's law kind of describes the relationship between pressure and a volume of a gas. So you notice that there is an inverse relationship. So as pressure is going up, volume is going down. The formula for Boyle's law is listed over here, which is P1V1 equals P2V2. So what we're going to do is we're going to use the formula to kind of answer some gas law problems relating to Boyle's law. So the first example is talking about a sample of helium gas. A sample of helium gas is compressed from 200 milliliters to 0.24 milliliters. The pressure is now 3 atm. We want to figure out what is the original pressure of the gas if the temperature remains constant. So what we're going to do is we're going to use Boyle's formula and we're going to plug in for information that is given to us in the problem. So it's telling us that a sample of helium gas is compressed from 200 milliliters to 0.24 milliliters. So 200 milliliters is going to be our V1 and our 0.24 milliliters is going to be our V2. We don't know what our P1 is, but we do know that the pressure is now 3 atm. So what we can do is we can solve for our P1. The first thing that we're going to do is we're going to multiply 3 and 0.24. What we do is we're going to multiply these two and then divide by 200. When we do that, we get our answer of P1 that equals 0.0036 atm. We're not going to talk about sig figs for this problem. The second example we have is, it is hard to begin inflating a balloon. So a pressure of 800 kilopascals is required to initially inflate the balloon to 225 milliliters. What is the final pressure in atm when the balloon has reached its capacity of 1.2 liters? So what we're going to do again is we're going to plug in for the information that's given to us in the problem. So we have a pressure that is in 800 kilopascals. What we're going to do is we're going to put that as our P1, kPa. Right? It's telling us that the initial balloon was 225 milliliters. That is going to be our V1. Our P2 is what we're trying to look for in the problem, and then the final V2, which is 1.2 liters. Okay, so in order to solve this problem, we're going to first multiply 800 by 225, and then we're going to divide that by 1.2 in order to get our P2. When you do that, you see that our P2 is 150, and the units is kilopascals, because that's what our pressure unit is. The next law that we're going to talk about is Charles's law. So if you remember Charles's law, we talked about how Charles talked about the relationship between volume and a temperature of a gas. So the formula looks like this. V1 over T1 equals V2 over T2. So remember that this is a direct relationship. So as volume goes up, temperature is also going to go up. And also, if volume goes down, temperature is also going to go down. So we're going to use Charles's law now in order to answer a couple of problems. The first example is this. The temperature inside of an oven is about 70 degrees Celsius. If I place a balloon in an oven that initially has a temperature of 22 degrees Celsius and a volume of 0.5 liters, what will the volume be when it is fully heated? So one thing that you need to remember for Charles's law is you always want to change the degrees Celsius into Kelvin. And if you remember how to do that, degrees Celsius, all you need to do is kind of add 273 in order to get your answer in Kelvin, your temperature in Kelvin. So what we're going to do is we're going to read the problem and we're going to plug in for information that's given to us. So we know that the temperature inside the oven is 70 degrees Celsius. If we change 70 degrees Celsius to Kelvin, all we need to do is add 40 plus 273. And that is going to give us a temperature which is 313. So what I'm going to do is I'm going to put that as our T2. Right? If I place a balloon in an oven which initially has a temperature of 22, when you change that to Kelvin, you get your Kelvin temperature as 295. Alright, and a volume of 0.5, which is going to be our initial volume, which we're going to put over here for our V1. Right, in order to solve this problem, what you need to do is you need to first divide 0.5 by 295, and then you're going to multiply over your 313 on both sides in order to get your V2. When you do this, you should have get an answer of 0.53 liters. The next Charles' Law example is a soda bottle is flexible enough that the volume of the bottle can change without actually opening it. If you have an empty soda bottle, which has a volume of 2 liters, at room temperature at 25 degrees Celsius, what will the new volume be if you put it in your freezer at -4 degrees Celsius? So remember, you always want to change your degrees Celsius into Kelvin before plugging it into Charles's law. So when you set up the problem and kind of write everything that you are given in the problem, your setup should look like this. 298. And then we're solving for our V2, and we have our T2, which is 269. So stop the video and solve this problem and see if you get a correct answer. When you're solving this problem, the first thing you want to do is take 2 and divide it by 298, right? Then what you're going to do is you're going to multiply over 269 on both sides of the equation in order for it to cancel out. 269. Ultimately leaving you with an answer for your V2. When you do this problem correctly, you should have got an answer of 1.81 liters. The next 2 problems are you-try problems, so pause the video and answer this problem, these 2 problems, and then check back to see if your answers are correct. Okay, so when you checked back and you tried these 2 problems, this is kind of how you should have set up the problems and the final answers that you've gotten. For the first problem, your V2 will equal 0.0049 decameter cubed, or you can see that it's equivalent to 1 liter. And the second problem, you should get a temperature of 51,826 degrees Kelvin.